Welcome to EDU World Space.
So in this video, we're going to talk about question 30 from chapter 20, which says the United States Public Health Service, or USPHS, recommends the fluoridation of water as a means of preventing tooth decay. The recommended concentration is 1 milligram of fluoride ions per liter. The presence of calcium ions in hard water can precipitate that added fluoride. What is the maximum molarity of calcium ions in hard water if the fluoride concentration is at the USPHS recommended level? And then we're told that the KSP of calcium fluoride is 4 times 10 to the minus 11. So what is the KSP again? The KSP is what's known as the solubility product constant, and that's just the equilibrium constant for the dissolving of a compound. So that's the equilibrium constant for this reaction, where we have CaF2 at equilibrium with Ca plus 2 and 2F minus ions. So we know that we can write the equilibrium constant as the product of the concentrations of our products divided by reactants raised to the power of our stoichiometric coefficients, excluding the reactants or products that are not in solution. So for example, our CaF2 is not included here. So when we calculate the solubility product constant, the equilibrium constant, we're doing it from concentrations that are at equilibrium. So if we use concentrations from equilibrium, we have the equilibrium constant. But if we use concentrations that are from before we reach equilibrium, we have what's called the reaction quotient Q. So we know whether or not a precipitate formed based on the size of Q of our reaction quotient relative to KSP, our equilibrium constant. So if Q is greater than our KSP, that's kind of a way of saying we have more ions in solution than we would at equilibrium, then our precipitate is going to form. So we know our KSP, and we know our inequality. We know that we want Q to be less than or equal to KSP because we want to avoid our precipitate forming. And we know our fluoride ion concentration. And then we're just solving that inequality for the calcium ion concentration. But we were given the fluoride ion concentration in units of milligram per liter. So let's take a minute to convert that to moles per liter, to molarity. So we know that there are 1,000 milligrams in every gram. And then we know that the molar mass of fluorine is 19 grams per mole. So we divide by 1,000 and divide by 19, and we end up with 5.3 times 10 to the negative 5 molar. So that's our fluoride ion concentration. So now, again, we want to write our inequality so that Q, our Ca plus 2 times F minus squared, is less than or equal to the value of our equilibrium constant, our KSP. So we write our equilibrium constant, which is 4 times 10 to the minus 11, and that's greater than or equal to our calcium ion concentration, which is our unknown variable, times our fluoride ion concentration squared, times 5.3 times 10 to the negative 5, which is what we just calculated, squared. So then we just divide both sides by 5.3 times 10 to the negative 5 squared, and we end up with 0.014 is greater than or equal to our calcium ion concentration. So the maximum calcium ion concentration is 0.014 molar.